Have you ever wondered how you can log into your favorite apps using your Google or Apple account? Or how online payments work so seamlessly? The answer lies in APIs, powerful tools that connect different software systems and make our digital experiences possible. In this video, we'll break down the fundamentals of APIs, explore their various types, and dive into the architectures that power modern web and mobile applications. Whether you're a beginner in development or just curious about how apps communicate, this guide will help you understand the backbone of today's digital world. Let's get started by uncovering what an API really is. API stands for Application Programming Interface. Think of it as a set of rules and protocols that allows different software systems to communicate with each other. APIs define how applications request services and exchange data, acting as a contract between a client and a server. This means developers can connect systems and use built-in features without needing to understand all the complex inner workings. APIs simplify development, making it easier to build powerful applications by leveraging existing services and data. Imagine you're at a restaurant. You, the customer, place an order with the waiter, who then communicates your request to the kitchen. The kitchen prepares your meal, and the waiter brings it back to you. In this analogy, the waiter is the API, the customer is the client, and the kitchen is the server. APIs handle requests and responses, letting users interact with complex systems without needing to know what's happening behind the scenes. In the digital world, when you make a payment online, the API securely sends your information to the payment processor, verifies it, and returns a confirmation, all without exposing sensitive details. Technically, APIs work by having a client initiate a request to a server, specifying what data or action is needed. The API receives and authenticates this request, performs the necessary operations, and then sends a response back to the client. This response includes the outcome success or failure and any requested data. This process is the backbone of how apps, websites, and services interact, making everything from social media notifications to online shopping possible. APIs are essential in software development because they make connecting different applications and services much easier. Instead of building everything from scratch, developers can integrate external functionalities using standard commands. This not only saves time, but also reduces complexity. For users, APIs enhance security and user experience by acting as secure gateways that filter data exchange, protecting sensitive information while ensuring smooth and reliable interactions. APIs come in several types, mainly categorized by their accessibility and usage. The four main types are open APIs, partner APIs, internal APIs, and composite APIs. Each type serves a unique purpose, from enabling public access to facilitating secure internal communication within organizations. Understanding these types helps developers choose the right API for their specific needs and integration scenarios. Open APIs, also known as public APIs, are made available to everyone. They encourage developers and organizations to build applications, integrate services, and innovate using standardized access to data or features. Examples include APIs for financial market data, search engines, and social media platforms. Open APIs drive collaboration and rapid development across the tech ecosystem. Partner APIs are shared with specific business partners and typically require authentication and agreements. These APIs enable secure, controlled access to essential business functions, such as payment processing or data sharing between trusted organizations. For example, a payment API like Paystack allows businesses to process transactions directly with banking platforms, ensuring security and reliability. Internal APIs are designed for use within an organization. They help streamline internal processes by enabling different teams and systems to communicate securely. For instance, a company might use an internal API to connect its HR, payroll, and project management systems. These APIs are not exposed to the public, ensuring sensitive business logic and data remain protected. Composite APIs combine multiple API calls into a single request, making them especially useful in microservices architectures. When a single operation requires data from several services, a composite API triggers multiple underlying APIs and returns a unified result. For example, an e-commerce platform might use a composite API to fetch product details, pricing, and inventory in one go, reducing latency and simplifying integration. APIs can be structured in different ways, depending on the use case, scalability, security, and accessibility requirements. The most common architectural styles in web development are REST, SOAP, GraphQL, and gRPC. Each architecture has its own strengths and trade-offs, influencing how data is exchanged and how systems interact. REST, or representational state transfer, is an architectural style that uses HTTP methods like GET, POST, PUT, and DELETE to perform operations on resources. REST APIs are resource-based, meaning each entity, such as a user or product, is identified by a unique URI. REST is popular for its simplicity and scalability, making it a go-to choice for web and mobile applications. Data can be exchanged in formats like JSON or XML, and each request is stateless, containing all the information needed for processing. Requests can include headers and query parameters for authentication and data filtering. The server processes each request independently, returning data in the requested format and using HTTP status codes to indicate success or failure. This stateless approach ensures scalability and reliability across web services. Let's look at a practical example. A book API built with Node.js and Express. Clients can use HTTP methods to create, read, update, or delete books. For instance, a GET request to Volin Books retrieves all books, while a POST request adds a new one. The server processes the request, updates the database, and returns a JSON response. This approach is widely used in web services, mobile apps, and cloud integrations for its simplicity and scalability. SOAP APIs are defined by a WSDL document, which acts as a contract between client and server. This makes SOAP ideal for enterprise applications that require strict standards and robust error handling, such as banking and healthcare systems. SOAP APIs operate by encapsulating data within an XML-based structure called a SOAP envelope. This envelope contains a header for metadata and a body for the actual request or response. A WSDL document describes the service's operations and data types. The SOAP processor parses the XML, executes the requested operation, and communicates through a specific SOAP endpoint, ensuring standardized and reliable interactions. A typical SOAP API use case is in banking, where secure operations are critical. For example, a client sends an XML request to retrieve account details or process a money transfer. The server responds with an XML message containing the requested information or confirmation. SOAP's strict standards and robust error handling make it a trusted choice for industries that demand reliability and security. GraphQL is a query language and runtime for APIs developed by Facebook. It allows clients to request exactly the data they need in a single request, reducing overfetching and underfetching. The heart of GraphQL is its schema, which defines the structure of data, types, and relationships. Clients can query, mutate, or subscribe to data, making GraphQL highly flexible and efficient for modern applications. In GraphQL, clients construct queries specifying exactly which data fields they need. The server validates the request against the schema, uses resolvers to fetch the data, and returns a JSON response containing only the requested information. Clients can also use mutations to modify data or subscriptions for real-time updates. This approach improves efficiency and flexibility in data retrieval. A common use case for GraphQL is in e-commerce, where clients need to fetch product details, reviews, and stock availability in a single request. The schema defines the data structure, and clients can request only the fields they need. This minimizes unnecessary data transfer and optimizes performance, making GraphQL a favorite for mobile and web apps that require efficient data handling. gRPC is a high-performance remote procedure call RPC framework that uses HTTP and protocol buffers for efficient binary data serialization. It supports synchronous and asynchronous communication, as well as streaming, making it ideal for microservices and real-time applications. gRPC's service contracts are defined in protofiles, and it generates client and server code for seamless integration. With gRPC, developers define service contracts and message types in protofiles. The code generator creates client and server stubs, enabling remote procedures to be called as if they were local functions. gRPC supports unary, client streaming, server streaming, and bidirectional streaming, all over HTTP. Interceptors and metadata can be added for authentication and logging, ensuring robust and secure communication. A ride-sharing app is a great example of gRPC in action. When a user requests a ride, the app sends a compact binary message to the back-end, which responds with driver details. The server can also stream real-time updates, such as driver location, directly to the client. This efficient, low-latency communication is perfect for applications that require real-time data exchange and high performance. Selecting the right API architecture depends on your project's needs. REST is simple and scalable. SOAP offers robust security for enterprise systems. Let's compare the four main API architectures. REST offers moderate performance and high scalability, with simple implementation. SOAP is more complex, but provides strong built-in security. GraphQL is intuitive for clients and efficient in data fetching, while gRPC excels in performance and is ideal for microservices. Each has unique trade-offs, so understanding these differences helps you make informed decisions for your projects. APIs are the backbone of modern software, enabling seamless communication and data exchange across platforms. As technology evolves, we'll see more AI-driven APIs, decentralized architectures, and enhanced security measures. Low-code and no-code platforms are making API development accessible to everyone. By understanding API fundamentals and architectures, you're prepared to build and integrate the next generation of digital solutions.